All right, so we're going to get started with the section today is called data distributions. So data distributions just means ways of calculating measures of central tendency and then how we can use those to put them onto a plot. So a Boston-Lister plot is what we're going to talk about today. And that's going to use the measures of central tendency that we have. So when we say central tendency, what does it mean? Like, what does tendency mean? If you have like a tendency to be late, what does that mean?
If you do it usually.
You usually are late, right? So if you have a tendency to eat pizza on Fridays, that means on Fridays you usually have pizza. All right, so tendency is sort of like what things usually do. Central tendency is talking then about when things are usually in the middle. So when things are kind of tending towards the middle. And we have 4 different ways to measure central tendency. And how many of you guys have seen these before? Mean, median, mode, and range. Okay, so mean, median, mode, and range. So we're going to go through and we're going to do a definition, and then we're going to talk about how to find it. And we're going to use that one up at the top, the number of hours Isaac did homework on 6 days. 3, 8, 4, 6, 5, and 4. So that's over the course of 6 days. Those are the amount of hours he spent doing homework. What is mean? What's another word for mean? Average. Yeah, it's another word for average. And how do you find the mean of a set of numbers? Diego?
So basically what you do is you add all the numbers together and divide them by how many you want.
Add them all up. Add the numbers. And divide by the number of numbers. Or number of things.
Sets of numbers.
Yeah. Alright, so in this case we would divide by what? 6, because there's 6 numbers in that list. Okay? So the first thing we would do is add up all the numbers. So 3 plus 8 is 11 plus 4 is 15 plus 6 is 21 plus 5 is 26 plus 4 is 30. So we've got 30. And then we're going to divide that by 6, which means our mean is 5. So that means on average he did how many hours of homework a night? 5 hours of homework a night. Okay? Is that accurate?
No.
What's throwing that off? What's making that? Because that's kind of a high number, right? Compared to most of the numbers in the list. So how come that number is a little higher maybe than you would expect? Brendan? I added them all together? Okay. And what was one of the numbers? What's the number you think that threw it off that made it a little bit higher than it should be? 8. 8 made it higher than it should be. Because one day he did 8 hours of homework, which was a lot different than the other days. Okay, most days he did 3 or 4. So the average there is 5 hours of homework a night. Okay, what is median? It's the middle number. So the median on a highway is the cement thing that goes up the middle of the highway. So the median is the middle. And how do you find it?
Least to greatest.
Least to greatest. So you got to put them in order. So put the numbers in order. And then do what?
Like hash them down, like what's the last one and then the
Cross off the ends until you get to the number that's where?
middle.
Yeah, find the middle number. Okay, now, this list is not in order, so if I were to put it in order, what would it look like?
3, 4, 4, 5, 6, 8.
Alright, so 3, 4, 4, 5, 6, 8. Now, I can cross off the edges, so a lot of times this is what people do. The only problem is what just happened. I have 2 numbers that are in the middle, because if I keep crossing, then all my numbers are gone, right? So what do I do when I have 2 numbers that are in the middle? Add them up and divide by 2, so you're finding the mean, the average of those 2 numbers. So you do add them up and divide by 2, or you would say what number is in the middle of those 2. So what number is right between 4 and 5? 4.5. So we say 4 plus 5 equals 9. 9 divided by 2 equals 4.5. So there's our median. Alright, so our median is 4.5. So you add up the 2 middle numbers. Now sometimes you won't have 2 middle numbers. It'll cross off really nice. And you'll just have 1 number left, and then that's your median. Alright, what's the mode? What's the mode?
Same number.
Same number shows up the most. Yep, number that shows up the most. our list, what number shows up the most? 4. Because 4 showed up twice. Alright, so the mode shows up the most, and 4 shows up the most. What if no number is repeated? There is no mode. Sometimes there isn't a mode. Alright, or if you had another number show up twice, like if you had 8 show up twice, there wouldn't be a mode there either. Okay, it has to be a single number that shows up the most. And then last but not least, what's the range?
Big number minus.
Big, which we call the max. Max minus min. So in this case, what's our maximum? 8, and our minimum? 3. So our range is 5. So those are our 4 measures of central tendency: mean, median, mode, and range. Okay, when do we use these? When will we find the mean? Well, like what purposes do they serve? Because you guys have probably learned this. I think by the time I was a freshman, this is like the 3rd time I learned it. I feel like I did it in 6th grade, maybe in 7th or 8th grade too. But it's like, why do I need to know this? When would I ever use the average?
You can use it like for graphs, grades.
Okay, for graphs and stuff. What do you mean by graphs and stuff?
Graph, like a bar graph.
Okay. Yeah, so you can find the average something like, let's say if we did the problem we talked about yesterday with the football and the baseball attendances, you could find the attendance for the course of like 6 years, right? You could add them up and divide it by 5 or however many years it was. Good. What did you say, George?
Like a teacher whenever you're doing grades.
Totally. Whenever I calculate your grades, I use your average all the time. Okay, so average is something I use all the time. You guys do it in college readiness, right? When you're figuring out, like, what do I have to get on the midterm to pass this class? You're finding the average, right? So a lot of times like when I look at data like this, the average is important. The median is really important for me too, because the median means that half the people in the class did better than that, and half the people in the class did worse than that. So I want the median on a grade to be as high as it can. So like again, I said this I think yesterday, I'm pretty happy when the mean and the median are in the 80s. Like that means that like half the class got above an 80 and half the class got below an 80, and that's a really good score, okay? So we use those all the time for things like that. Average, like, we might say, if I'm making a budget or something like that, like what's the average amount that I spend on groceries every week? So that's how much I need to budget over the course of a year for groceries, okay? So we might use average to figure out things like that. Okay, so an outlier we talked about in the last class, but an outlier is essentially just a much different value. So the outlier here, if all of the data is down here, and then there's a much different value over here, what happens to your mean? It's higher, right? Where would you expect, if you saw this list of numbers, like just this data, where would you expect the mean to be? Somewhere like in the middle of all that data, right? But so like, picture for instance, let's say these are test scores. And let's say everybody got in the 70s, but then someone got a 99. So if I say the mean is like an 80, is that accurate? Is that really a true example of how most people in the class did? No? So what should I do with that outlier?
Take it away.
Yeah, you kind of want to take it away. If you're figuring out the average, you want to take it away. So for example, Niall scored these on 6 geography tests, so 70, 74, 72, 71, 73, and a 96. Which of those would be an outlier? 96. Why?
Because it's way.
Yeah, it's way higher than all his other grades, right? So Niall should be proud of that grade, right? But his average, his usual performance on geography tests indicates that he's probably, if he were going to take another one, where would you guess he would end up? Probably somewhere in the 70s, okay? Because usually he ended up with those in the 70s, and then 96 is an outlier. So just keep in mind, sometimes outliers can sort of throw off your data. It doesn't make it wrong. Like, it's still correct that his mean was a 76, but that's probably higher than it should have been, given that he had a 96 on one of those tests. Okay, so at your boards, you're going to do all 4 of these. Keep in mind, the first 2 are already in order for you. The second 2 are not. So 3 and 4 are not in order, so you have to do that first. Go. All right, so we use these measures of central tendency to make what's called a box and whisker plot. And a box and whisker plot is a way of plotting our data so that we can really see where the bulk of the data is located. So the whole point of doing this again is to get good familiarity with medians so that we can use those to find box and whisker plots. Essentially what a box and whisker plot does is it puts our data onto a number line, but rather than just smashing all the dots for all the data onto one number line, a box and whisker plot organizes it in a way that splits it up into what's called a quartile, and a quartile is spelled like this. Alright, does that look like any word that you've seen before?
Yes.
Quarter.
What? Quarter. What's a quarter? 25 cents? Okay, what about a quarter in a football game?
1/4 of the game.
1/4 of the game. So a quarter splits things into fourths. So a quarter of a dollar is a fourth of a dollar. A quarter in a game is a fourth of a game. So quartiles split our data into 4 groups. And the data is split by median. So the lowest value for a box and whisker plot a box and whisker plot essentially is just going to take those quartiles and put them onto a number line. So if we have data, let's say we're talking about the number of times that people are, the amount of TV that people watch during the week. Okay, so over a course of 5 days, let's say you watch 2 hours one day, 4 hours one day, 3 hours one day, 6 hours one day, 1 hour one day, and then 7 hours one day and 2 hours one day. So here's a set of data that includes all these hours. To make a box and whisker plot, you need to identify various parts of the data or various numbers in the data. The first thing you have to do though with your data is, what do you think you should do with it first? Least to greatest. So we want to put it in order. So our first is 1, 2, 2. And then we go 3, 4, 6, 7. So we're done with this because now we've got it in order. Okay, so a box and whisker plot is going to cover all of this on a number line. So then I'm going to plot my number line. And my number line is going to include all the numbers from 1 to 7. Alright, so there's my number line. Now, there's 5 different numbers that we're going to put onto our number line. We're going to put our maximum, our minimum, our median, and then our first quartile and our third quartile. And again, quartiles just split it into fourths. So essentially the first quartile is your, like, between your first and your second, and then the third quartile is between your second and your fourth quarter, or your second and your fourth quarters. So we're splitting it up into 4. So what's our maximum in our list? 7. What's our minimum? 1. Our minimum is 1. And what's our median? So to do the median, we cross out each of these 1, 2, 3, 1, 2, 3, and we end up with a median of 3. Alright, so there's our median. Alright, I'm going to plot these onto the number line, and I'm going to plot them above. So I'm going to put a dot for 1, a dot for 3, and a dot for 7. And that's my maximum, my median, and my mode. Sorry, my maximum, my minimum, and my median. Alright, now, to figure out the first and third quartile, essentially what those are is just the median of each half. So take a look at 3. 3 was our median of the whole thing. So take 3 out of it. Now the first half is this set of numbers. The second half is this set of numbers. So the first quartile is just the middle number in this set, which would be what? 2. So your first quartile is this right here. Alright, so 2 is our first quartile. How about we find our third quartile then? Same thing on the other side. So what's the middle number here? 6. So our third quartile is 6. So I plot those as well. So I plot my first quartile at 2 and my second quartile at 6. And then this is where the box and whisker plot comes in. So my whiskers are on the ends. So my whiskers are just lines. And then the box connects the first to the third quartile. And then you just put another line right here. So that's a box and whisker plot. Those are the 5 values that you need to plot a box and whisker plot. Now, you're probably looking at that thinking like, why would I ever need to do that, right? So what this box and whisker plot tells you is because this is a lot smaller, this first box, see the first box, how it's a lot smaller than the second one? That means the first half of your data is a lot closer together, whereas the second half of your data is really what? Really spread out. So the first half of the week or whatever, the first half of the days, he watched about the same amount of TV, whereas for the other days, it was a really wide range, right? So a couple days it was like 1 hour, 2, and 2 hours, which are pretty similar. And then it was like one day he watched 4, then he watched 7, then he watched 6, so it's a lot different. Okay, so a box and whisker plot is going to tell you basically where your data is lumped. So your data here is lumped closer together in the first half than it is in the second half. These whiskers kind of represent outliers. Okay, so most of your data is in the box, and these whiskers kind of just represent outliers. Okay, so that's a box and whisker plot. So you need to be able to find these 5 pieces. Max, min, and median tend to be pretty simple. First quartile and third quartile, the easiest way to do it is to just circle your median and then look at them like 2 separate halves. So here's your first quartile, and then use this half for your third. So we're going to try one more together. All right, so this is a much larger set of data, but still the first thing we have to do is what? All right, we still have to put it in order from least to greatest. So this is what's going to take me probably the longest. So I'm going to move this up just a little bit so that we have a little more room. What's my smallest number? 2. I see, yeah, it looks like a 2. And I'm actually going to cross these off as I go so I don't forget anything. So there's a 2. Do I have any 3s? Yes. How many? 3. I see 1, 2, 3. Am I missing any? No? Okay, so 2, 3, 3, 3. Do I have any 4s? Yes. Yes? How many? 1, 2, 3. Are there any others? No. Okay, so 1, 2, 3. All right, what about 5s? Yes. Yes? Just 1, 5. Any 6s? No. No? Any 7s? Yes. How many? 1. 7. How many 8s? How many 9s? 2. 10s? 2. And then 11s? 1. And 1, 2, 12s. I almost fit it. And a 14, right? So 14 down at the end. So that's everything. So there's my list. Now what's my minimum? 2. So that's the first one we're going to do, 2. What's my max? 14. My max is 14. Then which one should I find next? The median. I want to do the median next because I need that to find the first quartile and the second quartile. So I'm going to count from the outside, and I'm not going to cross off as I go because I'm going to need to cross off later. So I'm just going to count and put dots underneath. So 1 here, 1 here. What's my median? 8. Now, I want to circle it so that I know my first quartile is coming from all the numbers to the left of the circle, and my third quartile is coming from the right. And in this list, I'm just doing what now? How do I figure out? I'm just finding the median again. And this time I'm going to cross them off, because once I've found these medians, I'm done, right? So I can cross off the ends. And my first quartile is what? 4. And then my third quartile is 10. All right, what do I do with all those? Put them onto a number line? My number line needs to go from what to what? 2 all the way up to 14. Do I skip numbers? No. now what do I put? What do I do? Plot what?
Median.
All 5 of them, right? So I put dots, all 5 dots at 2 and 4 and 8, 10, and over here at 14. Where do my whiskers go? From the 2 to 4 and 10 to 14. And then my box goes here. And then I'll put another one here. Alright, so where is the bulk of this data? Most of the data is crowded together into the first half or the second half? So this is spread out, right? Yeah, so where is it crowded together? Second half, so that means the bulk of your data is here in the third quartile, because that box is smaller, which means it's a more crowded box. Okay? So most of your data is between 8 and 10. Alright, now, on that box and whisker plot, I'd say for the most part, people are really good at remembering minimum, maximum, median. The first quartile and the third quartile is just finding the median again. What would have happened if there had been 2 numbers here? Add them up and divide by 2, but you circle both. Okay? So you circle both, so then your halves would be, like, they don't include whatever's in the circle. Alright, so go try one. Skip this. Go try this one. The number of grapes on each of the 15 bunches in a grapevine.